Hello guys, recently I got a request to demonstrate how the 55 timer IC works in a stable mode of operation. As we know, the 55 timer is a general purpose or multi-purpose IC, but I'll be looking at on how to configure it and the working principle of it in a stable mode of operation. As we all know, the a stable mode indicates that it's not stable in either of the modes. So it's not stable on the on state or on the off state. So it fluctuates between the on and the off. So that being said, let's get to know the components we'll be using for the project. So here I have a breadboard and a 9 volts battery that I'll be using with a connector, the 9 volts battery and its connector. So I have a 10 UF capacitor. I'm using a 10 UF capacitor and a couple of resistors, 1K, 10K and 20K resistor. I'm using an LED to indicate or show the output of the project. I'll be using a jumper wires for establishing connections where necessary. And of course, the brain of this project, the 55 timer IC, which is the IC we'll be using. This is an 8-pin IC. It has 4 pins on each side. So this IC is the IC we are going to configure in a stable mode of operation. So we have the pins from here, pin 1 down to pin 4. Then we have pin 5 and to pin 8. So without wasting much time, let's see the pin out of the IC. So here is a real diagram I have, where we have our pin 1 down to pin 4, then 5 to 8. So the pin 1, as indicated, is the ground pin, which will be connecting to our negative side of the battery. Then we have our pin 2, the trigger pin, the pin 3, which is the output pin, where we'll be getting our output signal. Then we have our pin 4, which is the resetting pin. The reset pin, which is the pin we'll be using to reset the IC. We have our pin 5, the control voltage pin, pin 6, the threshold pin, and pin 7, the discharge pin. Then lastly, the pin 8, which is the plus VCC pin. So as we have pin 1, we'll be connecting it to the negative side of the battery. We're connecting it to the negative side of the battery. That's the pin 1. While our pin 8 will be connected to the positive side of the battery, as well as the pin 4. We are connecting the pin 4 to the positive side, that is to pin 8, to ensure that the IC resets itself. And we'll not be using our pin 5 for this project. We will leave it floating. There will be no connection on it. So that being said, let's see the diagram we're working with. So here is a diagram I set up. So we have the IC. We have the IC here. So this is the pin 1. This side is the pin 1. So we have pin 1 there. As mentioned earlier, it's connected to the ground pin, and we have our pin 8, which is connected to the plus VCC. And if you look closely, you'll see that the pin 8 is linked to pin 4, the reset pin. As I said, it is for resetting the IC. So we'll connect it to the positive side. While we have our pin 2, the trigger pin, connected to the pin 6. This is done to ensure that these 2 pins, this one we connected the 8 to 4, is for the resetting. So one is to ensure the charging and discharging, which is being set with this resistor, this 20K and 10K. So from the junction where we have this pin 2 and 6, we connect one end of this 20K. Then the other end will be connected to pin 7. Then we have to connect, just after we have the connection of pin 4 and 8, we'll connect our 10K. Another end we connected to pin 7. These two resistors here are the timing resistor. They control the discharging through this discharge pin, the pin 7. They control the discharging and discharging of this capacitor we have at pin 2. So here is the capacitor we'll be using, the 10 UF. So we'll be connecting the 10 UF here, and these are the resistors, this 20K and the 10K. So after we are through with this connection, this is the timing resistor as I said earlier, and this is the timing capacitor. This resistor here controls the charging and discharging of this capacitor, which in turn places the IC in a stable mode. Now, as we have the pin 3, now which is the output pin, we will be connecting it to our LED. But before that, we'll be connecting it through a resistor to limit the current. As I said, we'll be connecting this 1K to the longer side of this LED to limit the current flowing from the pin 3 to the LED to avoid damaging it, and the shorter side will be connecting it to the ground as indicated in the diagram. So that being said, as I've been saying earlier, and just through this tutorial up to now, I've been saying that this is a stable mode configuration. So I have a real formula here to get the frequency that we have the IC working on. So it's being gotten with F equal to 1.44 divided by the product of the summation of R1 and 2 R2. That's the product of this 1.44 divided by R1 plus 2 R1 times C1. The C1 is the charging capacitor, and these two resistors here are the timing resistor, which we will be using to control the charge and discharge of this capacitor, which will now place this IC, as I said earlier, in a stable mode of operation. So since we have established that it's now in a stable mode of operation, we'll be generating, or we'll be having a square wave signal at this pin 3 that looks like this. It goes from the high side to the low. Here we have the negative and here we have the positive. So it goes from this positive down to this other side and comes up again. It continues this way. So the number of cycles, or the number of going from the up to down in a second, gives rise to the frequency. As we know that frequency is number of cycles in a second. So that being said, let's now move down to the breadboard. I have this IC already set up here from the diagram we have here. You place your IC. Then, as I said, we'll be connecting our negative pin, the pin 1, to ground. So I've chosen this side to be my ground side. So I'll be connecting the pin 1 to ground. So I've done just that. Then I'll be connecting my pin 2. I'll be connecting, pin 8 to positive. So this side is my positive side. So that being done, I will now move further to connect my pin 4, the reset pin, to pin 8. So after connecting my pin 4 to pin 8, as you have it, which are connected to the power rail, the positive side, I now have to connect my pin 2 to pin 6. So here I have my pin 6. I'll connect it to my pin 2. So I have it set up this way. And next thing we have is to connect the resistor, the 10K, from the pin 8 to pin 7. So as I said, we will be connecting this pin 8 to through this resistor to pin 7. Now next thing is to connect our pin 6 through our 20K to the pin 7. So as you can see, I've connected that. So what's left is connecting our capacitor. As we have this capacitor, this is a 10 UF capacitor. So the longer side is the positive, and this side with the dash is the negative. So I'll be connecting this positive side to pin 2. As you can see, the side with this dash is connected to our pin 1, which is the ground pin. So let's now connect our pin 3, which is the output pin, through this resistor, the 1K. As I have this 1K connected, now I'll connect the LED from this longer side, which is the positive, just where I have the connection of the 1K. Connect the positive side down to where I have this pin 1. So as we can see, we have everything all set up. So now it's now time to bring in the power. As I said, this side is my negative side, while this side is my positive side. Now let me get the battery and connect my negative to this side and connect my positive to this side. As you can see, the LED comes on and goes off at a given time, which is given by this frequency here, and in turn controlled with these resistors and capacitor. What is happening here is these resistors control the charging and discharging of this capacitor, which brings on this LED and generates a square wave signal. So as we can see, we have everything set up. This is the Astable mode of operation. We have successfully configured it. As you can see, it's not stable on the on, neither is it stable on the off state. It goes on and off at a given time. So more like a recap, this is the pin out of the IC, and this is the diagram we used. This is the formula to get the frequency, and this is the circuit we used. Thanks. We have everything set up. Very nice and simple. Though it might look rough here because I don't want to make everything complicated. So if you follow it step by step, you'll be able to get what we did here. We just used a single capacitor, a timing capacitor, 10 UF, and 3 resistors, 20K, 10K, and 1K, with an LED. The 1K here is used for this LED to avoid damaging it. So that's it, and this is the main guy here, the IC that we used. So we just used a couple of components, just a single capacitor, 3 resistors, and of course the LED and the IC. So you can as well do such project on a breadboard, on a Vero board, which I've done, and I will leave some documents or every other information you'll be needing in a link down in the video description. So this is it. I'm off.